Okay, I'm just gonna go ahead and get started. So today I'm just gonna cover some like basic Python as well as give it like a brief introduction into QuantConnect. Okay, so um, okay, so let's just start with what variables are. Variables is where you can like store like information or data. So to create an integer, you just do like x equals 5, and let's just print what this x looks like. Okay, so for people who are familiar with other programming languages, typically you'd have like types. So in Java, it'd be like int x equals 5 or something like this. But in Python, the types are dynamic. So you can have it like, so it's an integer right now. So you don't declare the types. And the types are also like, variable can change its types. So what is this? Let's make it take on the value true now. And you can see that this is allowed. But in like a different language like Java, if we did like int x equals 5, then x equals true would not work. But types aren't fixed. Variable types aren't fixed in Python. So what should I? Okay, so this is Boolean. It can be true or false. So true or false. You can also have floats, which are basically floats are basically numbers just with decimals. So like here, this is an integer, and now this is a float. Okay. So okay, so the let me just do x equals true. Okay, so booleans and strings are basically ways to store character information. Like this is a string. And in other languages, you use double quotes, but in Python, both single quotes and double quotes work. So let's just look at what this looks like. So let's do y equals double quote Bob. And yeah, these are basically the same thing. It doesn't matter if you use single quotes or double quotes in Python. Okay, so these are variable types. These are different. These are what variables are, and the various types that they can take. Okay, so what are some operations? So let's do x equals 5, and then let's do x plus 6, and that's just addition. Or we could just do 5 plus 6. Okay, subtraction. Oh, subtraction. Multiplication uses the star symbol, which is Control 8. No, Shift 8. Shift 8. Division is 5. Okay. So in other programming languages, typically this would give like, here, let's do some. In other programming languages like Java, if we did 6 divided by 5, just like that, it'd probably be, we'd get 1 back because we just truncate everything because we int divided by int. And so what we get is an int back. But in Python, we do not, there is no truncating like with the default division. So you can see it's 1.2. But if we had like Java, if we had to use something like Java and we did 6 divided by 5, we'd get 1 back. So what happens if we want this like the other, like the commonly seen division, well, aka 4 division? Well, we can just use 2 backslashes. And this is what we typically see in other languages. And how do we do the power? We just do double asterisks. Here, let's do 3. No, it's 8. Okay, so that's basically most of the operations. Most of the operations in Python. Okay, functions. To create a function, you do def something, and then let's create a function called square, and we'll square whatever we put in. So square, and then let's return the square of x. Okay, so now let's call this. So let's print the square of 5. And that's how you create a function in Python. So on a programming level, why do we use functions? Well, the reason we use functions is to organize a bunch of lines of code into a task that tries into a block of code that tries to achieve one task. And they also allow us to reuse code. So if we can call square again, so let's call it square 6. So we can reuse this. Well, but what happens if we wanted to do something complicated, like it prints 1, print 2, 3. Like, so here we could do this, right? So what happens if I wanted to print 135 and the square of some random number? You could do square 5, right? But without functions, let's just copy this. Here, let's just remove this. Let's just have like print nums. Okay, so we could do, let's just call, so print, okay, so like this, we can call print nums multiple times. But what happens if we didn't use a function? We wanted to print all these numbers multiple times. Well then, so we could do that, and we could basically, but then we have to, what happens if we want to print these same numbers twice? Do we have to copy it again? We have to copy it again. So, but with functions, if we organize all of these bunch of lines of code, we can recall the same function over and over. And we don't have to copy paste it. That's kind of ugly. Because what are lambdas? It's an anonymous function. Like, so if you remember earlier, def square, we called it square, right? What happens if we don't want? Okay, so now let's create an anomalous function like square 2, square elf for square lambda equals lambda x power 2. Okay, so we could do square 2, or we could do square L. Yeah, let's just do that. And you can see that's the same thing. So why would this be useful? So, well, it's typically you don't have to use lambdas. You can always stick to functions, and you can always stick to using functions. However, the point of lambdas is for stylistic purposes. So say we have a function called eval, and it evaluates f for an x. So we can return f of x. And then how does eval and double. So we evaluate the value and we multiply it by 2. Okay, so now let's do eval and double on a square function. So let's create a square function, square x, return x. Okay, so we can eval and double. Let's pass in our square function. And then we pass in, let's just do 2. Let's just put in 2. And we get square, so 2 to the power of 2 is 4, and then times 2 is 8. But well, this is a lot. So I just used up 2 extra lines of code. What happens here? What happens if we use the lambda function instead? We get the same result, and thus we don't need that. And this function doesn't have a name. That's why it's called non-anonymous function. The function we used earlier is called square. And that's the point of lambdas. It is to make your code look cleaner. Okay, so control statements. So it's basically so if something, so these control statements usually examine the Boolean. So let's create a x equals 5. So if x is greater than 5, then print okay, so let's try this. Okay, so that's an if statement. Okay, so let's do 4. It is not okay. Now that evaluates to false. Oh yeah, wait. hopefully you guys, okay, so these evaluate to Boolean. Here, let me go back up here. So operators. Okay, so these are different type of operators. These are Boolean operators. So 6 is greater than 5, and then that'll return a Boolean. Okay, is 6 less than 5? That's false, so it returns false. Is 6 equal to 5? False, but 5 is equal to 5. So basically just math. It's just like typical math operators. It does what you expect it to do. So if it's true, okay, so what happens if it's not true? If x is okay, if x is divisible by 2. Oh wait, yeah, that's another operator. Okay, so this is another shit. Okay, so 5. Okay, so this is basically remainder. It takes the remainder of. So we do 5 divided by 4, and then we take the remainder. So it's 1, right? Because like okay, so can you guys see my paint? Just put like type something, say yes in the chat, or like. Okay, thank you. So we do 5. Okay, so we do 5 divided by 4, right? So we do this 1. Okay, 4 does not fit into 1. So we have here. So 1, then R 1, right? And this is what the modulus gets us. The modulus. This is what the modulus returns. That makes sense. Okay, what's 6 modulus for? Then it'd be 2, right? 7 more. Okay. That'd be 1. Okay. So if you modulus 2 and it gets you 0, that means it's divisible by 2, right? Because like, right? Okay, so 2 are 0, right? Because this is an even number. Oops. Modulus 2. Okay, so 8 is the even number. So you get R0, right? And then 6 is the even number, so you also get R0. So that basically says X is even. X is even. So let's try that out. So that's what if. Or we could just have else. So if we don't want another question, X is not. Okay. So, or we can have or we can have another. Okay, let's just do divide by 2 equals 1. That means it's odd. So we can have like multiple. We can have like multiple elifs, and then we can add another elif. Blah blah blah. Okay, so what's a for loop? Okay, so for loop in other languages are kind of weird. I mean, no, for loops in Python is kind of different from for loops in Java or some other language. So if we want to iterate from 0 to 9, we do for I in range 10, and then we print I. So that's print. Okay, so in like some other language, it'd be like for. It'd be something like this. Print. Or if it's Java, it'd be system.out.print. But so it might be a little difficult to get used to, but that's how you do for loop. So for loop just calls the function. So for I in range, okay. So range is just creates like a collection of numbers from 0 up to this value. So we take for I in range because it's elements from 0 to like 9, we go, so I goes to 0, then I gets assigned to 0 first, then it gets assigned to 1, then it gets assigned to 2, blah, blah, blah. So that's how for loops work in Python. So for I in some like collection. So let me go over what, here, actually, let me go over what a data structure is. Okay, so what are collections? It's basically like a list or something. Like, okay, so data equals, okay, so we can put like stuff in here. And that's just the list of elements. And we can like get some, so if we want the first element, we do 0. What happens if we wanted to add something? Like, let's just append, okay, so we'd use append. So let's just add like a 4 in there and let's print it out. So that's what lists are. Okay, so we can, so for I in, let's create a list. 1, 2, 4. All right. So you can see here, it takes this I, assigns it to the first element of the collection. Takes this I, assigns it to the second element of the collection. Takes this I and assigns it to the last element of the collection. And then that's why the I prints out 1, 2, and 4. Okay, so that's a for loop. So while loop does something while something is true. So while true, okay, so let's just have like some integer, like, so I equals 10. While I is greater than 3, print I. And let's have it do this. Okay, so as expected, we print everything that's greater than 3. Oh yeah, you don't need this parentheses. Okay, so how can we simplify this? We can actually use, that's actually equal to minus equal. So we could just do that. Here, how about this? Well, we can also do plus. Okay, so if I, okay, you can also do plus equal 1. So plus equal 2 or something. So, okay, so these two are equivalent. These two are equivalent. This is just the shorthand of doing that. Oh yeah, also there's no plus plus. This is not legal in Python. You can't actually do that. For some reason, Python just doesn't have plus plus and minus minus. So if you want to just do increment or decrement, it's plus equal 1. It's kind of weird, but it's whatever. Okay, so let's go over what dictionaries are now. So like you have a bunch of key value pairs. So to create so earlier we had a list. We used like these brackets, right? But to create a dictionary, we use curly brackets instead. Well, yeah, okay. So let's just do like A is corresponds to 1 and B corresponds to like 2. Okay, so what happens if we like, so earlier we indexed by like the integer location, like 0, 1. Let's just, okay, so, oh yeah, it's 0. Oh, that's 0 indexing. So like, even though like, yeah, let's change this. Okay, so you notice that like, even though this is third element, it's the second element in programming speak, because this is 0th, this is the first, and this is the second. Okay, so this is dictionary. Okay. So we saw earlier, we used like an integer, but here we use these keys to index. So if we want this 2 here, we'd access it by B. Okay, so we got the 2 here, right? Because this B corresponds to 2, but let's try getting something that's not in there, like C. It's not in there, so we can't actually get it. If we try to get this through 1, we can't get it because there's nothing in here there's no key that is a 1. Okay, so how do we add something? So what happens if we want to add a C that is equal to 3? We just key it, then we set it equal to something. And then let's print D now. So now you can see that C's in that dictionary. So okay, so let's just print out. Okay, so okay? Now let's go over tuples. So tuples are basically arrays that can't be changed. Like so. Okay, it's so. I mean, lists that can't be changed. So like, let's just try to pen something. It doesn't work because you can't tuples can't be changed. So let's try to. Oh wait, I forgot to go over this. Okay, so let's just create this list. Oh yeah, how do you change an element for a list? You just access it and then set it equal to something else. And then you can do that with dictionaries. Okay, so we set the 0. So the 0th element used to be 1. Now we take the 0th element and it's equal to 2. So it's 2 to 6. Okay, so can we do the same thing with tuples? 0 equal 2. We can't because you can't change tuples. Okay, so let's create a dictionary. So D equals. Okay, so let's call it dot items. You notice here, this is like a list of tuples. And these tuples each contain like an entry. So why might this be useful? Well, it's not actually a list of tuples, but just think of it as a list of like 2-atom tuples. So why might this be useful? Like, why can't we just like, well, in the next topic, list and dictionary comprehension, we'll go over why it's useful. So just think of it as a list of tuples of the key values, where the key is in the first index of the tuple and the value is in the second index of the tuple. Okay, so let's just create a list. Okay, so what happens if we want like x squared? What happens if we want like 149? We want everything. We want every element. We want to create a new list that has everything squared of these values, right? So our target is 14449. So what? So we okay. So let's try that operator we introduced earlier. So we call square. Well, it doesn't work because we can't take the power of a list, right? Because it'd be like trying to do, okay, so power 2, it looks like this. And does that make sense? It doesn't really make sense. Well, like there might be like, we're not working with matrices. These lists don't behave like matrices or vectors or anything like that. So trying to multiply 2 lists together doesn't really make sense. So how can we square everything? So we can use something called list comprehension. So we can iterate through all the elements of X and then get something out of it. So if you remember earlier, we did for loop. So for I in X. And this will assign I to 1, I to 2, and I to 3. And then we get something on the left. It will add whatever we did to that list. So let's just X copy. So this will just be an X copy. So X copy. So that would just be the copy. Because so we have I set to 1, we stick it in the list. This I is stuck into the list. I set to 2, we stick it in the list. I set to 3, we stick it in the list. But we want this target here, right? 149. So what do? We square it. We square it, and we stick the square in the list. So let's look at this now. And that's what we get. We cube it. And that is what list comprehension is. What happens if we wanted to filter out everything that was odd? Well, we can add a condition here. So if something is true, so if I is odd, we can still keep this, we can still do operations. So let's just multiply all of the odd items by 3. And this is exactly what I would expect. We can do this for something very similar with dictionaries. Okay, so what happens if we want something similar? So let's just call this D target. No, let's just call this target. Okay, so what happens if we want 1, 4, 9? What happens if we want something like that, right? And then we'd also want like some add a y to each character, right? So what we can do is iterate it through the items. So let's just do d copy equals. So what do we want? So we want, for chart, let's do like C for character, and then I for int in d dot items. Oh yeah, here, let me just go over. Okay, so what happens if we did do like, let's just do. So we can, so here is, this is basically tuple. So what we do is we assign this tuple to the d dot items. So we assign, so this tuple, the ci is assigned to this a1. So this c is equal to this a, and this I is equal to the 1. And then we go to the next element in this list thingy. The c is set to b, and the I is set to 2, blah blah blah, etc. And we can actually just omit this, and it all works. So for ci and items, so what do we want? So we want the c to have a y on it, and then we want the I to be squared. So oops. Okay, so the key value pairs. I accidentally put a comma here when it was supposed to be like using a colon to make this a key value pair. And this is exactly what we get. And which is hopefully the next sense. Okay, so let's go over what classes are. Classes allow us to like store a bunch of information. Okay. Let's do this. Okay, so let's just create a class called person, and it has multiple different information. So init, if you're familiar with other programming languages, if you're familiar with coding, init is equal to the constructor of other languages. Yeah. So init is called when an object is created. So think of, so a person is, so we create a class person, and that's basically a template. So we are all people, right? And so there's a notion of classes and objects, and objects are a specific version of a class. So like Joe would be one object that is of a class person, but Joe is an object because he is a specific person. Okay, so let's just create a person with name, height. Just start. Okay, so self.name equals name. And what is this self? Well, self is the object. It's an instance of the object. And every, like you. Okay, so it'll make sense later. Here, let me just like. So the height equals height. Okay, let's just create a person. Let's just create a specific person. So from this class person, let's create a Joe object equals person. So the name is Joe, and he is height of 6. Joe.say name. Okay, so what happens if we don't have this self? Let's just put something random here. We need to pass in the self because basically it passes its, like, every time an object calls this function, it passes itself in. So what it basically does is it passes itself in implicitly. We don't need to specify. So this is what it looks like. This is what Java is doing, right? Because when we call a function on Joe, it passes itself into that function. However, because of Python, we don't need to add this. It automatically does it. And that's why we need to keep the first argument of every function in a class reserved for the self object. So just think of it like this, but it's implicitly done for you. So you don't need to explicitly pass it in yourself. Okay, so why do we need to do self.name equal to name? Like why doesn't it just store it? Like why can't it just store it? Like, well, that is because this name belongs to the scope. Like this. Oh yeah, let me go over what scope is. Okay, so like a lot of things have scopes. If else, so okay, so let's just do if true. So x equals 5. X equals 5, print x. And let's go outside of this if statement and try to print x. Okay, let's just comment this out for a second. So we print x. Well, that wasn't actually supposed to work. Okay, scoping Python is kind of wacky. Okay, actually, let's create a function. Wait, no. That's actually what's it. We're supposed to use a function. Okay, def print 6. Okay, let's try print 6. Print 6. Oh, I forgot the colon. What? Wait, no, let's do y. Okay, so I already put x, and because of collab, what it does is it stores these variables into like the background memory. So let's try. Okay, let's just try to print y now. What? Well, let's change this y to. Okay, now, okay, yeah, we've never used e, so there's no e in the local memory. Okay, so here, even though we specify e to be 6, it's because this e belongs to the scope of this function here, right? So just think of the scope, like indent. When you see an indent, it creates a scope. That's what scope is. Like anything inside this scope cannot go outside of the scope. So think of this indent here as like just like a cage. You see this, like, just pretend there's a line here, just like this indent where this indent area, it just creates like a box around this stuff. And so we can't access this e because it's inside the scope of the print6. Python's kind of weird. Like if statements allow stuff to come outside of the scope. So in like Java, if you had an if statement and you like declare like x equal 5, you wouldn't be able to access x outside of the like the scope of the statement, but Python you're allowed to. So there's like a lot of weird. And so this name disappears because it's outside of the scope. Like it's stuck inside here. It's stuck inside the scope of this init. So that's why we have to like put in anything, to store any variable, we have to store it to the instance of the object. So self.name equal name. Hence why I have that. And so why do we have classes? There's some like weirdos who argue against classes and believe like C master race. C doesn't have any classes. But classes are really nice because it allows us to reuse code multiple times and organize things into like organize stuff into like nice neat packages. So what happens if we wanted to create another person? Let's say Bob equals person Bob, and he's like 1 feet tall or something. What the? Bob. Oops. Bob.c. You can see we reuse this person class to create a Joe object and a Bob object. Hopefully that helps you see the difference between what a classes and an object is. Because a class is like a template, and an object is a specific instance of a class. Okay. Let's just, okay, so there's also something called extending classes. Okay, so you can actually, okay, let's make a student. And let's have it extend the person. Like person, student is a like specific type of person. Okay, so def init, self name, height, and then let's do ID for like the student ID. And we call super dot init name height. So it calls this the super. So this person is the super class. We go to the person here, then we call this init, and then self.id equals ID, and then let's do def say ID self print self.id. So let's create a Steve equals student. His name is Steve. And then his like ID is like, and then Steve dot say ID. We can also do Steve dot say name. We can also access Steve dot height. That is because when we extend a class, we inherit everything. We inherit this say name function, we inherit this stuff, we just inherit everything. And so why do we want extension? Well, that is because like what happens if we have another class called class teacher, right? Then we can also make it another person, and then class staff or something, coach. And so these are all people, and so we can reuse that. Python's polymorphism is kind of weird, so don't try polymorphism in Python. Okay, so that's the basics of coding in Python. Hopefully that all makes sense. Okay. Okay, so now let's go over what Python. Let's go over what Pandas. So Pandas is a library. To install like a library, do people install Pandas? So if you use Google Colab, it automatically there's like a bunch of it. Or if you want to use TensorFlow, you just people install TensorFlow. I already have it installed, so. Oops. Okay, so we can import classes. So import math. So what we want to, okay, so then we want to do math.floor 1.02. We can also, okay, so what is this as thing? We can import something as something. Let's call it as m, and then we call it m dot. So we can just change it. But then if we try to use math.floor, it will not work anymore. Math.floor 1.02. Oh, I already imported math. Wait, yeah, math stored at local code. Okay, so actually let's import numpy as np. Actually, let's just restart runtime. Runtime. Okay, so import math as m. Okay, never mind. Okay, okay, just ignore that. I'm using collab, so collab environment is kind of different. But okay, let's just go over this real quickly. So, okay, so what is Pandas? Pandas is a way to organize data into like tables. It's a nice way to organize tables. And so we can see here, this is like a common server value. You can think of it as like a sort of a spreadsheet. So let's do pd.read CSV. So let's call df for df. Okay, so you can see here, so we read this into this data frame like object. And this is a data frame. Okay, so let's just print type df. Yeah, just prove that it is a data frame. You can see here, it's a data frame. Okay, it's a way for us to store like tabular data like this. Okay. So we store into like a bunch of like rows and columns, and yeah, that's basically. Okay, so we can actually create a data frame from scratch. So let's just see how that works. Let's just keep that. Okay, so this is okay. So df2 equals pd dot data frame data, and then df2. And so you can see here, so we specified a column name A, and specified a bunch of values in that column B, values in the column. What if we did this? They are not all the same length, so it won't actually work. So you notice that these are all 2, so that means it'll give us 2 rows. Okay, so how do we access a specific column of a data frame? So we just have this df. Okay, so df. What happens if we wanted to access the open column? We just type in open, and then we just have pandas series. So think of pandas series as like columns, and pandas data frame as a bunch of series together. But we can actually, what happens if we want like a 1 column data frame? So we specify, so you notice this is a list of 1 element. So you can do something like this. Now this is a data frame. Okay, so just to prove that as a list. Okay, so so now we got the open and time columns. Actually, let's just skip this. Okay, let's go over to QuantConnect. Okay, let's just go into what QuantConnect. Hopefully, you guys know enough Python to like just get started. I do not. Okay, so why should we? So QuantConnect is an algorithmic backtesting engine. Okay, so you can see here, this is all Python code. We could use C# if you want, but we can specify if you want C#. F# doesn't really work, so I wouldn't recommend that. But Python's where it's at, so I recommend using Python. Okay, so let's just create a simple SMA strategy. Okay, so before we trade anything, we need to call this add equity. Okay, so SPY is the this is ETF stock of like the 500 biggest companies in the US. Yeah, let's just do. Never mind. I'm just not gonna care about. Okay, so So what ad equity does is it basically subscribes to a ticket. Okay, so AAPL is the stock for Apple. Apple, if you know Apple. Okay, so why should we use ad equity? Like, why should we like subscribe to specific symbols? Like, why don't we just have like all the symbols? Why don't we just subscribe to all the symbols at the big? Like, why aren't we like automatically subscribe to all the symbols at once? Like, why do we need to subscribe to specific symbols? Doesn't that make it? Isn't that a little inconvenient? Okay, so maybe just have like 10 seconds to think about like why we subscribe to like specific symbols. Well, the reason we subscribe to specific symbols is because if we don't subscribe to specific symbols and we like have all the data for all the symbols at once, then we'd have so much data because there's like, if you think about it, there's around like over like 6,000 publicly listed stocks on the US stock exchanges. So if we had 6,000 points of data every minute, that'd be a ton of data that like, it just slow everything down tremendously. So by subscribing to specific symbols at the beginning, we know which data we want at the beginning. So we instead of having like 6,000 points of data at every step, we only have like 3 or 4 or like 10 or like 20. And so by subscribing to specific symbols at the beginning, we greatly reduce the amount of data we need. So let's just do raise daily resolution. So what's the difference between resolution? So daily resolution means like the candle. If you guys are familiar with candlestick, open, high, low, close. This information is different if you have like on a minutely basis or versus if you have on a daily basis. Because like on a daily basis, it captures a lot more fluctuations. So the high and the low is a lot wider. But if you have a minute doesn't give the stock price to move a lot of time to move. But a daily gives stock price a ton of time to move. So if you think about it, then the candles are different. So we want daily data. Okay, so on data, so every time we get a new candle of data, on data is called, and we get a data object, which is basically a slice object, and it contains a bunch of data for all the symbols we subscribe to. So let's just subscribe to self.add equity. Okay, so let's just so Apple price equals data dot. Oh yeah, we have to check if data dot bars if data dot bars dot contains key. So if, as I was talking earlier, every time on data is called is when we get new bar data. So this bars is like a dictionary of symbols as well as symbols that map to a bar of data. So if it contains AAPL, let's just work with AAPL for now. So AAPL price equals data dot bars AAPL. No, let's just do Apple bar. And let's just examine what this Apple bar is. So let's just go here, backtest, and then go to the debugger and look at the Apple bar. You can see here we get open, high, low, close information. So we can do Apple bar dot close to get the close, Apple bar dot open to get the open. Okay, so now that we get that out of the way. Okay, so let's create a strategy where we buy Apple stock if it is above its 5-day moving average. So how do we do that? So let's create a simple moving average offer. So self.SMA, let's create a variable equals self.caps SMA. Okay, so which symbol do we want it for? We want it for the AAPL. Hopefully you guys know what simple moving average is. It's just the moving average of the price data, but it moves. Like, takes the past 5 days, takes the average. So you can see. So you can see here. Hopefully you guys know that. Okay, so let's do the 5-day moving average, and we want the data used for the simple moving average to be on the daily resolution as well, which is the same as the way we subscribe to the data. Okay, so if self AAPL bar dot close is greater than the 5 days simple moving average of the AAPL, self SMA dot. So the SMA is an QuantConnect indicator object. So how do we get the actual value that the indicator has? So if you have like a 5-day SMA, and this is just the indicator object to like do all the dirty work, how do we get the actual simple moving average value out of this indicator? We do .current.value. Seems kind of weird, but just get used to it. Just every time you have an indicator and you want to access this, like the float value or something like that, just do .current.value. And then, so how do we buy Apple stock? So we can do self.market order. We market order APL, and let's just market order one. Let's just oh. Okay, so what happens if we, so typically you won't use market orders unless you're using like working with crypto data. What happens if we want to just send like 10% of our portfolio? And so here we set cash to like 100K. What happens if we want to spend like $10,000 on Apple stock? We can do .set holdings, and then we put a decimal, like 0.1 corresponds to 10%. So we just put a what do you call it? A like fraction, a proportion. I don't know. Okay. So that. Okay, so that's basic. That's just basic simple moving average. Okay. Okay, that's all I really want to go over today. I'm probably gonna go over more QuantConnect in the next lecture. So thanks for coming. Okay. Okay. Bye.